some history, some context to what I'm doing, I will open the problem for your part, which will describe the solution. And so we did. We wrote this book, and every time that we are presenting together, it happened 3 or 4 times online or in person, he's always saying, this is the book of Francesco. I wanted to help him to sell more copies because there is my name on the cover. And he's a friend. He's a person, you met him. He's very curious. He's very friendly. He is funny. He's open-minded. And he's hungry of innovation and solutions. You can't stop him. That's crazy. I like him a lot.
Yeah. So actually, he has wrote one topic for my next book coming in. So he'll be a co-author for me as well.
Okay, yeah, wow. We have something in common. Actually, I also have to write one topic for your book. So yeah.
I'm waiting for you on your Puppini Bridge. Right. Okay.
Sure.
Enough high level for audience. Let's jump into it.
Let's dive in. Yeah.
Let's deep dive into it. Let's go into this data modeling, tables, joins, primary key, foreign keys. Tell us about this Puppini Bridge. What is this Puppini Bridge?
Wait, I need to put myself comfortable. Okay. Let me tell you a story. So first off, I wanted to solve the problem of the fun trap when a number gets duplicated simply because of joining with another table. That was one of the things I wanted to address. The market already had solutions, so Business Object as a software was solving the problem to some extent. But yeah, even the theory, like everyone is using the 𝗏𝗏𝗆𝗏 approach for data analytics for one main reason, because it's the only approach existing. There is only the 𝗏𝗏𝗆𝗏 approach. Sometimes I speak with people and they say, we have chosen the 𝗏𝗏𝗆𝗏 approach. And I say, okay, you have chosen among which options? We mainly went for 𝗏𝗏𝗆𝗏. Yeah, exactly the point. So there is not another solution. There was not another solution. There is either 𝗏𝗏𝗆𝗏 or fully denormalized tables. These are the two approaches that exist today in data analytics. So all the world of machine learning is just making one large table denormalized, and all the people who have all the companies that have a BI tool, let it be Tableau, Power BI, Qlik, or whatever, they just do a number of dashboards. Each of them has a star or typically a snowflake schema. And it's all based on the concepts of dimensional modeling, facts and dimensions. But the real problem was not the fun trap. The real problem was actually 𝗏𝗏𝗆𝗏 itself. So I was feeling narrow in the approach of 𝗏𝗏𝗆𝗏. So I was working for Nokia first, then for Giorgio Armani, and then for many, many other companies. And every time I was seeing the same phenomenon, that the reports requirements were not limited to the approach that 𝗏𝗏𝗆𝗏 suggests, because 𝗏𝗏𝗆𝗏 says you have fact tables and dimension tables, and you watch the facts through dimensions. Okay, yeah, that's one of the use cases. But there are other use cases that go beyond this. That's why all the people that I speak with, they don't say we use 𝗏𝗏𝗆𝗏. They say we use sort of a 𝗏𝗏𝗆𝗏-ish approach. 𝗏𝗏𝗆𝗏. What is this 𝗏𝗏𝗆𝗏-ish? Well, it's because 𝗏𝗏𝗆𝗏, with all respect, it doesn't answer some of the basic needs the companies have. Let me give you an example. According to 𝗏𝗏𝗆𝗏, two fact tables cannot point to each other. So a fact table joins two dimensions. But look at the example of sales and shipments. This is the example. That's my MVP, which is not minimum viable product, but minimum viable problem. So it's just a problem of two tables. They are both fact tables because they describe a process, they quantify it with facts, with numbers, and they typically have a date. But each shipment that happens because of an order, a row of sales. And so these two fact tables are by their business nature connected to each other. So the row of shipments has the key that points to the row of sales. 𝗏𝗏𝗆𝗏 calls that key a degenerate key, a key that points to nothing. Well, it's not true. It would love to point to sales, but it doesn't point to sales because if it was the case, you would have a fun trap. So Kimball noticed that when you join two tables, they have different grains because one row of sales can have 3 rows of shipments. It could be that you can break down in multiple shipments. Well, that the sales amount becomes triple.
Yeah.
That's what a fund trap is. So Kimball says, no. Don't do that because it's dangerous. Just watch your sales through dimensions, watch your shipments through dimensions, or call an engineer who will shrink your sales and shipments to the same granularity that can be a granularity of sales ID or even more aggregated. So there will be a third fact table aggregated with both facts. And that fact table you can explore through dimensions. That's also fine. But the problem is that by doing so, you find some of your answers in one star schema, some of the other answers in another star schema. For example, you want to see for each row of sales if they have been fulfilled, so the sales amount and shipment amount are the same amount, so you can do it through the aggregated table. But then if you want to click on one row of sale and see the 3 dates of the shipment, in that dashboard you don't find them. So you need to close that, open the other one that has the detail, but that one that has the detail does not compare the numbers. Well, I wanted to solve that problem. And that's why I invented the unified star schema. With the unified star schema, this is just an example, but these two types of requests, they all fit into one single dashboard. So the experience of a business user is that I'm opening the dashboard of sales and shipments. That's it. I find there all that I need. So I guess now your next question will be, how do you manage that?
No, so the thing is, we will travel on to the same example. You are saying sales and maybe marketing, right? When you say they create another aggregated table so they can reduce the granularity, right? Now, this is where, let's bring your Puppini bridge. You are saying between these two fact tables, do you bring this Puppini bridge into the middle? Am I right to say that?
Yeah, that's correct. Yes.
And then you load it. You load it with kind of keys. You load it after fact tables are loaded, or you load it into the parallel, like from source, how you load this Puppini bridge?
Okay, so we need to spend a time on how we merge data, first of all. The common perception in the community of developers is that when you have all your data that you need in one table, life is easy. But when you have the data that you need in multiple tables, you need to join them. That's the perception. But joining two tables is not the only way of computing together two tables. There are also other ways. I would name, there is the join, there is the lookup, which is slightly different. And then there is the in-memory association offered by the BI tools. And then there is the union. But I like to focus on the union. The union is an operation that at the beginning doesn't look very promising, because the join is basically you're putting the columns, let me go this way, you're putting the columns of your two tables next to each other. So this way you align those things that you want to compute together on the same row, and then you're able to have your insights. The union is weird because you're putting the rows underneath each other. So it's the opposite operation. Instead of this, you're doing this. So, and at the beginning, that doesn't look amazing because you still have put in the same table the two things that you wanted to see together. In this case, it's the sales amount and the shipment amount. But they are in different rows of your unioned table. But here's the trick. The trick is to do the union and then the aggregation. So it means that imagine that you have a table of 100 rows of sales and a table of 150 rows of shipments, because some sales have multiple shipments. 100, 150, okay? So we are not at the Puppini bridge yet. We are just at the union. So if you want to join them, so put the column next to each other, your tables of 100 and 150 rows, when you join it, it will probably have 150 rows. Or you shrink your 150 rows of shipment, losing some of the columns, because when you shrink, you lose some information, and then it becomes 100, and then you join them so you can compute the numbers together. They are on the same row, but you have lost the shipment date, the parameters that are unique for shipment, and so on. That is what people do. Instead, imagine a union between these two tables. So you will have a table of 100 plus 150, so it's 250 rows. And you say, what do I do with this table? Well, think about the BI tools. They are amazing because in a BI tool, you have the aggregation out of the box. In a BI tool, when you drag and drop a measure, you have just one number. If you associate this measure with the gender, and gender has male and female, you will break this number into two numbers, male and female. So you have automatic aggregation. It's a feature that comes out of the box of every BI tool. So here's the trick. You have a table of 250 rows. And of course, the columns, they are lined up, they are piled up whenever possible. So if you have in your shipment table the sales ID, you pile it up with the sales ID that is in sales. And then if you have the client ID, you pile it up. So you're building columns that are populated in both blocks, which I call stages in the Puppini bridge. So this way, you're creating a large table with a big spaghetti of columns. It's a bit ugly, but at least you have the two things that I was telling you before. You have them all there. So you can build this information for each sales ID. What is the sales amount that was supposed to do and the shipment amount that happened after that. They are now on the same row because they are initially on two different rows, or two or more, let's say one row of sales and three of shipments. So they are on four different rows. But with the magic of BI tools, you drag in your BI tool sales sales ID, and then you drag the sales amount and the shipment amount. And the shipment amount, which was distributed on three rows up there, now it shrinks into one row. So you have the aggregation on the fly.
Because however, you remove shipment ID, it will aggregate. Yeah,
exactly. Don't think in terms of removing, because in a BI tool, you bring everything inside the memory of the BI tool, but then it's bottom up. You start from a blank sheet and you add things.
You drag and drop. You don't
drag and drop into a blank sheet. First the sales ID, and then the sales amount, and then the shipment amount, and your report is done. It's done. And now you see for the first time on the same row the sales amount, and those three rows of shipment amount, they are all shrunk. And you can compute together, you can make the percentage or the difference. So that works. But in the same dashboard, now that you've done the union, we are not at the Puppini bridge yet. You've just done the union.
Yes.
In the same dashboard, you can also see for that row of sales, maybe in another tab, but still reading from the same data set in that dashboard, you're able to see the 3 dates of those 3 shipments, and if they were traveling by plane or by train, and who was the employee that was taking care of that shipment, all aligned. You could still do it comma separated when you're applying the 𝗂𝗏𝗆 approach. You can still keep these parameters, but you don't know anymore which employee was doing the shipment by train. So you lose the alignment of the information. With the union, you don't lose that information. You are able to build in on a separate sheet of your dashboard the list of the shipments with all their details. So you had no loss of data. With the union, you have no loss of data. Hello, everyone. Welcome back. So we have seen the union. Cool, great. However, with 2 tables, it already looks a bit weird. With 57 tables, it's going to have a lot of columns. It's a big spaghetti of columns, which is problematic. Take the good part of it and discard the bad part of it. Let's build the Puppini bridge. The same example as before, you have 100 rows of sales and 150 rows of shipments.
Yeah.
Now take only the keys and the numeric columns that you will need to use as measures later.
Keys and numeric columns. Okay, I'm with you.
So you will take the sales ID, you will take the shipment ID, but you also take the sales ID from the shipments. So it's you pile them up together. If you have information about the client, the product, the agent, the employee, you pile them up. If you have one date for sales and one date for shipments, it's very easy. You pile them up together because they are potentially a foreign key to the calendar. And then you take the sales amount and the sales quantity, whatever other measure you have in sales, whatever other numeric column you will aggregate by sum or average. And then you take the measures from shipments. So you take the shipment quantity, the shipment amount, and